Go.
Recording in progress.
All right, so crash course part 3 for 2024. How much of you all recognize these formulas? These formulas are given on the exam paper. It's part of the formula sheet. It's the sum and difference formulas. I'm talking about this part over here. How much of you all could say that, hey, I've seen those formulas probably in lessons or probably in school? So the table to the right, this is basically surd values. For example, if you were to find sine to t on your calculator, you will realize that the calculator would show you a half. Or if you sine 45 on the calculator, you will get a crazy decimal. But if you express that decimal as a fraction, well, in this case, a surd fraction, it will be 1 divided by the square root of 2. Now, for the exam, you have to memorize these values. Like the cosine of t is the square root of 3 on 2. These are values that you need to memorize. Also, sometimes in the exam, the angles are not given in degrees. Some of you all know the angles as radians by heart already because you did it in integration. For example, 30 degrees is the same thing as pi on what? 6. 45 degrees is the same thing as pi on 4. 60 degrees is the same thing as pi on 3. And 90 degrees is pi on 2. Now, these are the values in radians. So you can put a small c to the top. Then that's a symbol for radians. Now, like I said, we did all of this before. Today is just practice questions on this. So for people who don't have this, let's quickly do a screenshot and we will move to the questions. All right, so here's your first question. You have to try to figure out the value of sine 75 without a calculator. Now, just for fun, I want everyone to type in sine 75 on their calculator. Just type in sine 75 and just tell me what decimal you get. Just for fun. And then we're going to see if we can get the same answer without a calculator. So round it off to 2 decimal places, obviously. Make sure your calculator's on degrees mode. And if you type in sine 75, I am getting this. 0.9659. Obviously, you could round it off. I'm just, trying to be as accurate as possible. So 0.97. So everyone should be seeing that on their calculator. Now, let's just say your calculator magically blew up and you had to figure out this. How much of you have literally no idea on how to proceed with that question? So to do these questions, the examiner will set it up in such a way that you have to use values from the table. Like it will be normal angles, like 50 degrees or 60 degrees or 45 degrees. 75 degrees. Do we all agree that 75 is the same thing as 45 degrees plus 50 degrees? And these two angles from the previous table, I will call them, well, what's a good word for them? Very common angles that you're supposed to be super familiar with. All right, so instead of saying sine 75, I could say sine 45 plus what? 30 degrees. Isn't that the same thing as saying sine 75? This come like the first angle, A, or alpha, and this come like the second formula, angle, B, or beta. Let me just put, I think I had alpha and beta on the last one. So I don't know if you all recall this formula from the last page here. It had a formula called sine. Let me just clear up some space, right? I need all the space that I can get here. I can't waste a single pixel. So we know sine 75 is the same thing as sine 45 plus 30 degrees. Obviously, you can have it the other way around, 30 plus 45. So this comes like alpha and this comes like beta. On the previous slide, you would have seen this formula. sine alpha plus beta is the same exact thing as sine alpha multiplied by cos beta plus sine beta multiplied by cos alpha. And like I said, alpha comes like the 45 degrees and the beta comes like the 30 degrees. So it's just to throw it into the formula. Well, let's write it above here. This is 45 and this is 30. Let's see what we get. This really means sine 45 degrees multiply. Obviously, there's a secret multiplier in between here, but we can ignore it, I guess. We just imagine it. Cos 30 degrees plus sine, how much is beta? Beta is 30 degrees cosine 45 degrees. Everyone take down up to there. Now we're pretending we don't have a calculator. Now remember, we're supposed to memorize certain values for the exam. How much is sine 45? Go back on the table and replace it with that. Go and find out from the table how much is cos 30 in third form, and then do the same thing for these two. So all you're going to do is replace the items in the black circles with the third values. And then we're going to try to do what? Simplify it without a calculator. So for those who think you could finish it, take a shot and see if you can. If you look at your table, you will have realized that sine 45 is the same thing as 1 divided by the square root of 2. Let me just double check that. Sine 45. Yep. So we have 1 divided by the square root of 2. The cos 30 from your table is the same thing as the square root of 3 divided by 2 plus sine 30. Well, that's a half. That's an easy value. And cos 45 is also 1 divided by the square root of 2. So it's just to simplify this as much as possible. It's not going to be, this cannot be simplified too much, but you can multiply the top by the top and the underneath by the underneath. 1 multiplied by the square root of 2, square root of 3, sorry, is the square root of 3. Square root of 2 multiplied by the square root of 2, but you already can't do anything much there, right? Plus 1 by 1 is, well, 1, can't do anything much there. And then you have 2 multiplied by the square root of 2. Now, 2 multiplied by the square root of 2 is the same thing as square root of 2 multiplied by 2, right? I guess it really doesn't matter which order you write it. So you see this one underneath here? I just want to switch it around so it looks like this one. 2 multiplied by the square root of 2. Right, you'll realize you can find the LCM here if you wish, right? Not if you wish, you should. That's a better way of phrasing it. The LCM is obviously 2 multiplied by the square root of 2. This into this is 1. 1 multiplied by the square root of 3 is the square root of 3. This into itself is 1. 1 by 1 is 1. Do me a favor. Type in this on the calculator and tell me if we get the same answer as when we started class. Remember, we had gotten 0.97, but when you type it in on the calculator, write the top in brackets, right? Otherwise, the calculator will mess it up. Type in open brackets is square root of 3 plus 1. Close the brackets and divide it by 2, multiply by the square root of 2. And tell me if you get back 0.97, the same answer at the beginning of class when we had cheated and used our calculator. You see how 75 was like this 75 here. 75 can be broken up into 2 easy angles. Like in this case, it was 45 plus 30. Let's change up this question and see if you can figure out what 2 values you need to replace it with. So I'm going to give everyone 20 seconds and then we're going to move on. So here's what we're going to do. We're going to change up this question from sine 75, right? We're going to change it up from sine 75. Let's say the examiner were to ask you, right, to find tan 15 degrees without a calculator. So just for fun, right? How much is, we're going to cheat first. I want you all to find tan 15 on your calculator and send the answer on the chat. tan 15 degrees, right? Right, so and I'm getting tan 15, when I work it out on the calculator, I'm getting 0.267 or something like that. Well, I know you're going to round it off or whatnot, right? So let's say that, well, we're not pretending. Let's say this exact question came in the exam. Find tan 15, but don't use the calculator. My question to you is, what can we replace tan 15 with? What two angles you can replace the 15 degrees with? And it has to be like, it had to be from like 0 to 30, 45 or 60 degrees. You have to come from those choices. Kenya, correct. Vishala, correct. Samir, yeah, yeah, I didn't see that one. Yeah, but Samir, that's also correct, right? But I'm not going to use that one. Brito is 5 and 10 from the table. When you had looked at the table at the beginning of class, did you see 5 and 10 on it? It has to be from 0 degrees, this list, 50 degrees, 45 degrees, 60 degrees, or 90 degrees. Samir, no, check it back, right? To me, the first thing that came to mind was 45 and the 30 degrees. To me, it have another one, but I'm choosing this one. Couldn't we replace the 15 degrees with 45 minus 30 degrees? There is another solution. Someone said 60 minus 45. That would also work, and that would also work. But the one I am choosing is 45 minus 30 degrees. Everybody okay so far, right? So this come like the alpha and this come like what? The beta. So go back to the formulas at the beginning of class, and you all would see this formula, tan alpha minus beta. Okay? Write down the formula for alpha minus beta, the one with the minus here, because it have the other version with the positive. Write it down. Obviously, you don't have to type it back on the screen, but you write it down in your books, and we will get started. Use it. Anybody have this? Is tan alpha minus tan beta over 1 plus tan alpha tan beta. That's the formula that we're looking that you would have seen on your formula sheet. We all in agreement with this formula? Great. All right. So what we have to do now, remember, the alpha comes like what? The 45 degrees, and the beta comes like the 30 degrees. So all you have to do now is go and replace the alpha, any alpha that you see with 45 degrees, any beta that you see with 30 degrees. And then you replace them with the values from the table, the third values, and you try your best to simplify. Substitution, a different color here. So it's tan alpha. Remember, we pretending alpha is 45 degrees minus tan beta is 30 degrees. 1 minus, this is tan alpha multiplied by tan beta. That's tan 45 multiplied by tan 30. All right, so start replacing them with the third values. I'm going to continue over here. Right, so, and this is what I'm seeing from the table, right? Tan 45 is 1 minus tan 30 is 1 divided by the square root of 3 minus, well, tan 45 is 1, that's this one here, And tan 30 again is 1 divided by the square root of 3. Now, I'm doing all of this from memory. Huh? So, Isaiah, you have the same thing. I think Alia, you were saying the same thing. Now, the truth is, if this is 1, and this is 1 divided by the square root of 3, 1 multiplied by anything is itself, right? So, you don't really have to put the 1 here if you don't want to. Start simplifying it. I don't think we should. I wonder if we can leave the answer like this. Yeah, I guess just now. Huh? 1 minus the square root of 3. Hold it. 1. We end up with the same thing on top. And oh, guys, no. I made a mistake. Anybody saw my mistake? It's a plus down here. Oops. I have the plus here, but I forgot to put the plus. So we end up with 1 minus the divided by the square root of 3 divided by 1 plus 1 divided by the square root of 3. Now, to be honest, I think we could simplify this a little bit. Let's take a chance now. This here is the top part, and this here is the underneath part. Let's simplify the top. Let's go over here. I have 1 minus 1 divided by the square root of 3. Isn't 1 the same thing as 1 divided by 1? So what's the LCM here? The square root of 3, right? 1 into the square root of 3 is the square root of 3. Square root of 3 multiplied by 1 is the square root of 3. Square root of 3 into itself is 1. 1 multiplied by 1 is 1. So that's what I got for the top, if I try to simplify it, right? So let's keep your eyes here. For the underneath, it's almost the same procedure, right? 1 plus 1 divided by the square root of 3. 1 is the same thing as 1 divided by 1. LCM is the square root of 3. 1 into the square root of 3 is the square root of 3. Square root of 3 multiplied by 1 is the square root of 3. Square root of 3 into the square root of 3 is 1. 1 by 1 is 1. So we're going to take the top and divide it by the underneath. I'm just hoping it makes it a little bit simpler, right? Let's see if it makes it a little bit simpler. So the top is what? The square root of 3 over 1. Sorry, this is the top part. And we're going to divide it by the underneath part, which is this. But in maths, when you have a divide here, doesn't the divide change to a multiply? And you flip this over here? It takes a little while in the exam to simplify, but you should try to do your best to simplify. Won't this and this cancel out? And this is the final answer I would write for the examiner. You would end up with the square root of 3 minus 1 on top, and underneath is the square root of 3 plus 1. Work out this on the calculator now and tell me if you get back the original answer. If you're doing this on your calculator, you should probably put the top in brackets, press divide, and put the underneath in brackets also. So that way you're dividing the whole top by the whole underneath. Let me know if you got back the same answer. 0.2679. Right? Right. To me, I think the examiner would prefer this. He would prefer that. So far, in the last 2 questions, I gave you the angle in degrees. Like I came out right and said, hey, find tan 15. Or the last question was sine how much? 75 degrees. But suppose they stop asking the question in degrees now, and they start to ask the questions in radians. Let's see how that changes the question now. They want you without a calculator to find cosine pi on 12. Now, here's the thing. At the beginning of class, I showed you or reminded you that pi on 3 is how much degrees? 60 degrees. Pi on 6 was 30 degrees. I'm talking about this is your radian version of the degrees. Pi on 4 is 45 degrees. And there's one more. Pi on 2 is 90 degrees. Now, these are the values you're supposed to memorize for the exam. Nobody will memorize the value of, like, how much degrees is pi on 12. The average person is not going to memorize that. But how can we get pi on 12? But first of all, you might not notice this, but pi on 12 is the same thing as 1/12 pi. I don't know if that was obvious. Pi on 12 is the same thing as 1/12 pi. So how can we get 1/12 pi from these pi values? Well, what combination? Will pi on 3 plus pi on 6 give us pi on 12? Right? You sure, Fakira? I don't think that will give you that. You can check it. Pi on 6 plus pi on 6 will not give you pi on 12. Huh? In fact, the LCM here is 6, right? 6 into 6 is 1. 1 by pi is pi. 6 into 6 is 1. 1 by pi is pi. So you get 2 pi on 6 because pi plus pi is 2 pi. This actually gives you pi on 3. You sure, Anastasia? Check that back. Check that back. You all come up with some combinations because this is the headache part of the question to figure out what combination to use. Isn't 1/12 the same thing as 1/3 minus a quarter? Check it on the calculator. Use your fractions button. 1/3. Somebody said a quarter minus 1/6. Let's see. A quarter minus 1/6. I don't think we'll get 1/12 there. Let me just double check it. I could be wrong. The LCM here is how much? 6 and 4 is 24. I believe that's the LCM. 4 into 24 is 6. 6 by 1 is 6. 6 into 24 is 4. 4 by 1 is 4. Yeah, so this one also gives us 1/12. All right, fine. That would work also. So there are two combinations we can use. I am going to use the 1/3 and a quarter. I think that's the safest one to use. So let's try that one. Let's try that one. So instead of finding cos pi on 12, this is the same thing as cosine pi on 3 minus pi on 4, right? Remember the formula from, well, at the beginning of class, let me write it here. Cosine pi on 3 minus pi on 4. So this is the formula that you're going to have to use. This is alpha and this is beta. Cosine alpha minus beta is cosine alpha cosine beta plus. And I'm mistaken here for the cosine. When this is a minus, the middle here is plus. Sine alpha, sine beta. Anybody want to double check it? Because I'm calling this from memory and I do make mistakes. Right? I do not want to work with the degrees. If the examiner in these types of questions give you the angle in radians, I want you to work the whole thing in radians. Right? Let's keep on the good side of the examiner. So start replacing the alpha and beta now. So we have cosine pi on 3 multiplied by cosine pi on 4 plus sine pi on 3 multiplied by cosine pi on 4. And remember, in case you can't remember, pi on 3 is how much degrees? 60 degrees. And pi on 4 is how much? 45 degrees. So go to your tables now. Cosine pi on 3 is really cosine 60 degrees. Use your table to get that value. Try your best to simplify it. Some of you all have CSEC calculators. I know some of the Casios, right? So if you type in cosine 60 it will give you the value in the insert form already. So you might not even need to go back to the table. Right. Cosine 60 degrees. How much is cosine 60? I think this one here is a half. Cosine 45 degrees is 1 divided by the square root of 2 plus sine 60 degrees. That's the one. Sine 60, I can never remember. I think this one here is the square root of 3 on 2. And cosine 45 degrees. I made a mistake here. This is supposed to be what? Sine. But fortunately, it will give us the same answer. Sine 45 and cos 45 is the same thing. Lucky for us. So that won't make a big difference. Right. So let's try our best to simplify this. Isaiah, I think, yeah. Sorry, you could be correct. Sorry. I don't know yet. 1 multiplied by 1 is 1. 2 multiplied by the square root of 2 plus square root of 3 by 1 is the square root of 3. And underneath is 2 by the square root of 2. The LCM here is 2 square root of 2. This into itself is 1. 1 by 1 is 1. Right? So Isaiah, you do something wrong here. The LCM is only 2 square root of 2. You have it twice underneath. This into this is 1. 1 by the square root of 3 is the square root of 3. This is my final answer. Look for your mistakes. Let me know when you see it. All right, so here's a question now. If sine E is, let's get my pen here. Well, sorry, you guys try this question. This is based on last term's work. I know I showed you all one of these questions here. Take 5 minutes, and of course, send your answers, on the chat. And this one, you're not allowed to use your calculator. So in this question, the angle A, from the information they gave us here, is in the 4th quadrant. So what you need to do is draw a right angle triangle in the 4th quadrant. And in the 4th quadrant, cosine is positive. So I'll put C here, but everybody else is negative. So sine is negative and tan is negative, which makes perfect sense. Look at the value. Sine A is negative 12 on 13. So it makes sense because any sine value in this region will have a negative value. So that's a sign the examiner didn't make any mistakes so far in the question. And in case you can't remember, what's the formula for sine? Sine is what? Opposite over hypotenuse from basic maths. Use that to help you out here. And also, whenever you have a minus sign smack in the middle, my advice is to write the minus sign to the top. So, put the minus sign by the 12. That should help you out also. Good luck. Since they gave us sine is minus 12 over 13, like I mentioned over here, the angle they're talking about is A. So let's replace that theta with A. Is opposite over hypotenuse. So it's really minus 12 divided by 13 because we pretending the minus sign is on top. So the minus 12 is the opposite side. The hypotenuse is 13. All you have to do is pretend this angle here is A. Opposite is minus 12 and the hypotenuse is 13. You could use Pythagoras theorem to find the missing side of the right angle triangle. I'll put it in yellow. All right. Now, but when you're using Pythagoras theorem to find the missing side of the right angle triangle, ignore the minus sign, right? So here's a regular boring side that you are finding, and the answer you get here is supposed to be positive because this yellow line is on the positive side of the x-axis. So it should be 13 squared minus 12 squared square root because you're finding a regular boring side. How much you guys getting for the yellow side here? 13 squared minus 12 squared. Work out that first and square root it after. You're supposed to get 5, right? But see it on the calculator, because this is 169 minus 144. That will definitely give you 25. The square root of 25 is 5. Now, this value, like I said, has to be a positive value because it's touching what? The positive side of the x-axis. If the triangle was on this side and you did the calculation and you got positive 5, all you have to do is just put a minus sign in front of the 5. So whenever you're doing the calculations to find the missing sides, ignore the minus signs, do your calculations, and the answer you get, reason out if the answer is a positive answer or a negative answer, depending on where it is situated. Right? And this minus 12 makes sense, right? Because this vertical line is below the x-axis, or another way of looking at it, this minus 12 is in line, it's parallel to the negative side of the y-axis. So that is why it should be minus 12. The hypotenuse will always be positive, no matter where it lands, right? That's an important thing, and the hypotenuse is always positive, always, always. So from this now, guys, and we could reason out how much is cosine A. How much is cosine A? Cosine is what? Adjacent over hypotenuse, right? So cosine A is 5 divided by 13. Adjacent divided by hypotenuse. Using that now, find sine 2A for me. And I'll give you a next hint. Sine 2A is the same thing as sine A plus another A. Go back to your formula. Remember with alpha and beta? It's just so alpha and beta have the same exact letter, A plus A. That will give you 2A. The formula for sine alpha plus beta would be sine alpha cos beta plus sine beta cosine alpha. But remember, both of them are the same letter as A plus A. So it will look like this. Sine A cosine A plus sine A cosine A. And you have the values for all of them above here. What's the value of sine A? Well, the examiner was nice enough to tell you it's minus 12 over 13. Multiply by cosine A, which you just reason out. Cosine A is 5 over 13 plus, how much is sine A again? Well, it's the same exact thing over here. Minus 12 over 13 multiplied by 5 over 13. I think you all could simplify that easy enough. Right? Send your final answer as a fraction. Remember, you're pretending you don't have a calculator. Right? All right, so we multiply the top by the top. Minus 12 by 5 is just minus 60 on 169. Well, minus 12 multiplied by the same minus, sorry, by the 5 will give you what? Minus 60. Now, I might have a positive here, but a positive and a negative is a negative. Everybody with me so far? Now, you don't really need to find LCM here, but if you want, 169 to 169 is 1. 1 by 6 minus 60 is minus 60. So to me, it is getting minus 120 over 169. I don't think this could simplify, right? School, check it back now. Look at my calculations here. And let me know if you see your error. How about the rest of you guys? You saw your mistakes? Cool. All right, so have fun with this one. We did quite a lot of these questions coming down to the end of last year, to the end of November and December. Remember, when it's 2 theta and you're solving for an angle, this one you can use calculators, by the way. You're supposed to add 360, one less than this number. So if it's 2 pi, you're supposed to add 360 once. Just a little refresher. Right? If anyone missed the trigonometry videos, you can easily find those on the AdMaths classroom. Just go on the AdMaths classroom, not the maths classroom, the AdMaths classroom. Scroll down until you see trigonometry, and you just do all the videos there, and you're gonna be fine if you're completely lost today. So when I have to solve, like, this is basically a solving for theta. So when you're solving for an angle, you have to make a judgment call. Is it a positive type of question or a negative type of question? How do you know whether it's a positive question or a negative type of question? I will refresh your memory just now. First of all, in the first quadrant, everybody is positive. So I'll put A positive, meaning all is positive. It doesn't matter if it's sine, tan, or cosine. Everybody is positive in that region. In region 2, right, or the second quadrant, only sine is positive. Everybody else is negative. In the third quadrant, tan is the only one positive, and everyone else is negative. In the fourth quadrant, only cosine is positive. Everybody else is negative. So that's the first thing. Now, I'm going to write back the question here. 2 cosine 2 theta minus the square root of 3 is equal to 0. Is this question a negative question or positive question? The truth is, it's too soon to tell. So when is the correct time to tell whether this is a positive question or a negative question? Well, let's begin to solve for theta. Who would we throw across first? The minus square root of 3. So we end up with 2 cosine 2 theta is equal to positive square root of 3. When you throw across the negative, you get a positive. The next person to throw across is this 2, because he's a secret. Multiply. When you throw across a multiply, you get what? A divide. It's still too soon to tell whether this is a positive question or a negative question. Who is next to throw across now? Remember, this is what we have here. Cos 2 theta is equal to the square root of 3 divided by 2. Only when it's time to throw across the sine, tan, or cosine, and now is the correct time. Now is time to throw across the cosine. Ask yourself, what value is waiting on this side at that point in the question? And this is a positive, right? So it's a positive type of question, but not only a positive question, a positive cosine question. So now ask yourself, in which 2 quadrants is cosine positive? Can you guys tell me? In which 2 quadrants is cosine positive? 1 and 4. Right, so 1 and 4. And remember the formulas for each quadrant, right? For the first quadrant, it's just alpha, like whatever you get on the calculator, basically. In the second quadrant is 180 minus alpha. In the third quadrant is 180 plus alpha. And in the fourth quadrant is 360 minus alpha. But we're dealing with the first and fourth quadrant. That's the only two quadrants. Alpha, sorry, the angle, cosine is positive. Right. So my advice to you is, for the time being, throw a cross cosine and tell me how much you get. What's the cos inverse of the square root of 3 on 2? How much is the cos inverse of square root of 3 on 2? And then you have to pause the question. You see, when you have to cosine inverse something, tan inverse something, or sine inverse something, you just have to pause the question and get all the possible answers and then continue the question. Like I said, if you're lost, right, it's because you probably missed the tutorials last term, and it's a real easy way to rectify that. It's just to go in the AdMaths classroom, look for the topic trigonometry, and go through all the tutorials. There's a lot of tutorials, right? Because you just don't reach questions like this in one session. It takes a good few sessions. Somebody said to put brackets, just so this stuff. Right. So this is where we reach now. Cos inverse this is 30 degrees. Now here's the thing, right? So the first answer we get is 30 degrees. What's the second answer for region 4, for quadrant 4? Because we pretending the alpha is what? 30 degrees. So what's the second answer? 360 minus 30, which is how much? 330 degrees. Great. Now we can't move on as yet, because look at this. 2 theta is equal to what? 30 degrees. And 2 theta at the same time is equal to 330 degrees. Now, because it's 2 theta, the general rule of thumb, if they're asking for the answer between 0 and 360 degrees, you just have to add 360 once to each of these answers, because it's 2 theta. So if it was 3 theta, you would add the 360 twice. It's always one less than this number. So that means 2 theta at the same time. Let's add 360 to this. 360 plus 30 is 390. And 2 theta is also equal to, add 360 to 330 for me. 330 plus 360 is 690 degrees. Now we're not finished. The aim is to solve for theta. And for each of these equations, we could solve for theta. Throw across the multiply, you get what? A divide. So essentially, you have to divide each of these answers by 2. And now you're finished with the question. After you divide everyone by 2, then you are finished. So send your 4 answers across now. Your final 4 answers. I'm getting 15 degrees here. Theta is, I'm gonna give a calculator. 330 divided by 2. 165 degrees. 390 divided by 2. 195 degrees. And the last one is 345 degrees. Now we're finished. All right, so we're moving away from, well, I show you all are happy. We're moving away from the trigonometry, right? And let's try some differentiation and integration questions. I'm gonna give you a 5-minute head start on this. One little tip: if you are integrating, please do not have the x underneath, right? So there's x to the power 3, throw it on top, and it becomes what? X to the power minus 3. Also, if you have y and you differentiate y once, you get what? Dy dx. If you differentiate again, you get d squared y dx squared. So if you're going downwards, it's differentiation. To go back upwards, you have to integrate. So that means if you start off with d squared y x squared, and you want to get back dy dx, you have to integrate. And if you are at dy dx and you want to get back to y, you have to integrate one more time. Right, so that's my little hint for that question. Right, answers now start to pop up. Remember, the first thing I had advised is to throw that x to the power 3 on top to get x to the power minus 3. Now, we started off with this, d squared y dx squared. So I know if I integrate this, I will get dy dx. So if I want to find dy dx, I need to integrate minus 2x to the power minus 3, but make sure I put dx here. This means you are integrating basically the letter x. So if you integrate this, you will notice there are no limits. So when you integrate it, you will get a plus c. You will need to figure out the value of c before you move on in the question. Take 1 minute, guys. When you integrate this, you will get dy dx. You add 1 to the power, so you have to add 1 to the power, and then divide by the new power, right? So I'll simplify it out here. So you add 1 minus 3 plus 1 is minus 2. And you divide by that new power, which happens to be minus 2. Now, obviously, the minus 2 and the minus 2 will cancel out. So dy dx is my x to the power minus 2 plus c. Now, they ask us to find the equation, which means we have to work our way up to the letter y, which means we're going to have to integrate one more time. But we cannot integrate until we find c. To find c is pretty easy. The examiner gave us a hint. They said at the point 1, 4, where x1 is the x coordinate and 4 is the y coordinate, the gradient at that point is 3. Now, I told you all at the beginning of differentiation, gradient and dy dx is the same thing. So when x is 1, dy dx is 3, giving us a real easy way to solve for c. So when for the gradient to be 3, x needs to be 1. 1 to the power anything is 1. Obviously, we solve for c, we get in c as what? 2. So this is what we know so far. dy dx is equal to x to the power minus 2. And now we know the value of c. You have to integrate one more time. Because if you integrate dy dx, you will get back y. You will eventually get y, sorry. That's a better way of saying it. Let's integrate this one more time. If we integrate dy dx, we're going to get what? Y. So we integrate dy dx, we get y. But obviously, we have to integrate this. Add 1 to the power, divide by the new power. I could probably do it up here. I'll simplify it after. Minus 2 plus 1 is minus 1. And then we divide by the new power, which is minus 1. And when you integrate a number by itself, you just add in an x. Now, I know this has confused people when they divide by minus 1. Remember, this is really 1x to the power minus 1. The 1 is understood. 1 divided by minus 1 is minus 1. And don't forget to put the plus c. Now, obviously, you don't have to put the 1, right? That's optional. But we still need to find what? C. And they gave us, using the same hint here, But this time we have the letter Y. We're using the point 1, 4, because this means when X is 1, Y at the same point in time is 4. So see if you all can get C there for me. And that's helping you out. Y is 4 when X is 1. Replace all the X's with 1, solve for C, and you're basically finished there. All right, so almost done, guys, almost done. 1 to the power anything is 1, but you have a minus sign waiting here, so you get -1. 2 by 1 is 2, so 4. But this is easy stuff. I shouldn't have to do this. So when you solve for C, anybody got 3? I got C as being 3. Right. So the final answer after I write it, so I'm going to run out of space here. Right. So I want to write back this equation with C in its place. I'm going to write the final answer here. All these arrows up. So y is equal to minus x to the power -1 plus 2x plus 3. Now, obviously, if you don't like the minus power, you could throw it underneath a 1, and it will be -1 over x to the power 1. But you should have no problem getting full marks up to this point, because we just realized C was 3. Right? Take a half a minute, and I just want to show you all where the crash courses are for AdMats.